we're looking at February. You can see there are no slots in February. There are no slots in March.
Okay, so while we wait, while we are setting up, um, are you like? Okay, let me just. How long have you been in this profession?
Let me say since 2008 as an apprentice
Okay,
under
2008.
a Drossman supervision before I gain admission to tertiary institution.
Okay, that's fine. Welcome, programmer. You're welcome, and
Yes,
Michael, too, you're welcome too. Okay, that's fine. Okay, so right now we're about to start because this is almost 5 minutes to the time. Okay, that's fine. So as you can see, today's topic is about foundation design and all that. Now, this topic, foundation design, it's a very important topic, and it's a very important course as far as structural engineering or civil engineering is concerned. Sorry, please, can we just mute ourselves so that the background noises are not that? Okay, that's fine. Thank you. So as long as civil engineering or structural engineering is there, foundation design is a very important course because of how how useful foundation is. Knowing that without the foundation, everything with that we have done on the superstructure or any other persons have designed is just will not be a reality. You understand? And all that. And in that course, most people don't pay much attention on foundation design, which I have also observed and all that. They pay much attention on the superstructural design than the substructure design and all that. Now, one of the reasons why I say they don't pay much concern on the foundation design is because you see someone now is designing, for example, designing like 5 or 7 or 8 story building and all that. He would spend time modeling everything, then checking everything, and then designing. But when it comes to the foundation now, you will see that most times they don't make the right choice of foundation. Yes, we have soil bearing capacity, which most times or which often what um like recommend for us the type of foundation for us to use and all that. But I have been in a project before where the soil report was not done properly and all that. The person actually recommended for a pi foundation at a bearing capacity of 97 and all that, and it was just a 3-story building. And then he recommended for a pi foundation, whereas RAP foundation can be okay for that. And then they have all done the design for that project and all that. During the costs of the foundation, that client was already like he was scared because of the cost of the foundation, knowing that pipe foundation is very much expensive to construct and to build. So the client was very scared because it only the foundation cost was running up to 400 million plus. That's around if I take it to dollars, that's around 400 or 300 and something $1,000. So the client was already scared and all that. Even if the client has the money, but he was scared and all that. That's Why will he spend such amount of money and all that? That was before I was called to come and now redesign for that structure and all that. So I was given the soil tests and all that. So the first thing I looked at was for the bearing capacity, the settlement, and then the nature of the soil. When I saw that, I saw, okay, slab raft, which is the mat foundation, can go for this and all that. Then I started doing my design for that structure. That was the structure I said about that has a 3-meter cantilever. That later, during the construction of that cantilever, because of the bad and temporal support, that cantilever had an issue because of the bad temporal support during the casting of that cantilever. So that whole project, I have to now redesign it and all that. Then I now proposed for a slab raft foundation, even if the even if the soil report was saying a pipe foundation. So when I did that, the cost of that foundation reduced from 400 million, which is around $300,000, to we spent on that project just for the foundation 100 and something million. That was around $100,000. So you could see I was able to save the clients about $200,000 and all that. Now, what am I saying in essence? Maybe the person that did the previous design for that structure just depended on the soil report without having a vast knowledge about foundation design and what will influence you to choose a type of foundation for a structure and all that. Because if you look at what they do in soil test and all that, for example, let me say you have a 10-story building. Yeah, they will use an assumed load and all that to calculate, understand. But the actual load is during when you have done your structural analysis and design, you will get the actual load. Most times it is directly it is somehow close to each other, the one they assume for the bearing capacity test and all that. But most times too, it is quite different and all that. Now, something happened during that process and all that. When during the construction of that raft foundation, the person that did the soil test came, which is the boss of the company, came and all that. He was saying that, why am I using slab raft when he said said on the soil report that is to be used for a pipe foundation and all that. So I now asked him just one question, because I've already looked at the soil report. I knew that soil report was like wrong. It was not actually done properly. So I asked him one question: when at what bearing capacity do you recommend for a pipe foundation? And during this question, almost all the contractors were there, even the client was there. So he was not able to answer that question. Then the client now asked him that he should answer the question which I just asked him now. That at what bearing capacity will he recommend for a pipe foundation? He wasn't able to answer. So one of the contractors now asked him, so how did you then say we are to use a pipe foundation and all that? Now, what the guy did was to send his boys. Understand? Maybe he was too busy. He sent his boys to go and perform the soil test and all that. Then maybe his boys has low experience on the soil test and all that. So they now giving the report, and then he just use a template and just figure out some things. Understand? And all that. So it was then he now started taking sample at site and all that. So but that alone was already too late, because he had already shown to the client that he didn't do the actual work that he was paid for, and they paid him very, very well and all that. Now, what am I saying? you can see that had it been they depended on that soil on that soil report, hoping that because it's a very big company, a very known company that did the soil report and all that, you would have seen that one, you would have wasted the client's money, you would have just buried that amount of money in the ground and all that, not knowing that a cheaper type of foundation would have been able to resolve that issue and all that. Now, most of these things ends up spoiling engineer's name, because what a client will say is that, oh, this engineer that did the design, I spent over how many million or how many $1,000 for just the foundation and all that. You understand? And people will be looking at that engineer, oh, that this engineer, maybe whenever he does a design for you, he like the cost is very bogus and all that. And most times you will not be able to afford for that, because our one of the goal of a structural engineer or a civil engineer is to make the structure to be stable while also looking out for the costs of that structure, because a good design should be stable and should not be too expensive for the client to afford. You understand? One of the projects that is dumped currently or for many years ago is one crossing a bridge through the Atlantic Ocean and all that. They all did the whole design and all that. Everything was okay, but the cost of constructing that bridge was too much, way too much, and all that. That even if they spend that amount of money, people that will be using that bridge, in fact, they like the usage will not be worth what they have spent and all that. That was why that crossing a bridge through that ocean is what is just abandoned and all that. So I use this scenario just to tell you that most times you can do a design, everything is perfect and okay, but if the client is not able to afford it and then they didn't build that structure, of what use is your design? So you can see that. So that was how we were able to, I was able to save that client's money and all that, and everything looks okay. Yeah, that's fine. So that's one of the effects if you don't understand about foundation design and all that. So that's why we are talking about today. Our discussion is about foundation design. Now, one of the things that made me to use this thumbnail for this particular course, which is the Tower of Pisa, which you can see here, Tower of Pisa, is because the main reason why this Tower of Pisa is what leaning after or during the construction, I think after the construction, is because of the foundation. The foundation was not properly done. One, because of the soil. They didn't use the right foundation, and there was a settlement and all that because of the soft soil that is there. So this caused this building to what lean to one side and all that. And it is observed that this building tilts 1 millimeter every year and all that. So knowing that this building tilts 1 millimeter every year, you can be able to calculate how many years it will take the building to tilt almost to the ground. But for now, they are just using it for tourism. But the purpose of what this building was designed for, which is the Tower of Pisa that you're seeing here on the screen, is no longer actualized because of the failure. You understand? The reason why they're using it for tourism and they allow few people to climb up to the top just to like have the feel is because the building is still stable, even if it is still tilting, but just that it will not be able to accommodate much or large number of people. That's why they allow few people to enter, so that at least they can be able to make the money which they spent building this structure and all that. Now you can see the effect of foundation design. Imagine that, let me say I'm the one, or you're the one that did the design for a client, how do you feel? How do you think they trying to see you? And even yourself looking at the building every day, you won't be happy. You understand? Because this alone can damage someone's career and all that. So that's why foundation design, it's a very important course, or yeah, course for everyone to look into or to have a bit understanding. Okay, that's fine. So right now, let me welcome some people first and check. I welcome Oluwatobi and all that. Now we will be discussing on foundation types, when to use the actual foundation, or how to know the actual foundation for a structure or for a building, knowing that what influences our choice of foundation is: one, the type of soil; two, the nature of the building, the height of the building, how many stories do you have, and all that. These things influences the choices of our foundation and all that. So right now, let me give room for Engineer Michael. Let's have let's know what you think about foundation design. Engineer Michael, let me know. I think you're
Yeah.
you're from Ghana.
Yes.
Okay, yeah.
Yes.
Okay.
Okay. Thank you very much. I think you have beautifully highlighted some of the things that we need to know about foundation design. Here in our country, one of the things that we have observed is that most of the time, a lot of people do not do the soil investigation, or do not contract an engineer to get the geotech report done, which is very, very, very important. Because if they were following the proper way of doing things, it could actually save them. They could get some cost savings in terms of the foundation, the way it is sized. So, for instance, here piles are not that very common. We tend to do mostly pad foundations or raft foundations. So, if let's say we are doing some high-rise building, then the raft foundations tend to be very common. But what are some of the things that we need to know to come to a decision as to why we are choosing a particular um, choice of foundation or the other? Just as you've mentioned, if let's say the nature of the soil condition, if let's say you are building in an area where the soil is very weak, based on the geotech report that you have received, um, sometimes they will give recommendations as to the type of foundation that you should do. However, as the design engineer, you should also be able to make a very good decision based on the information that they have given you. You don't always have to follow strictly what is in the report. It helps, but then you have to make the final decision. So let me give a scenario. Let's say you are working on a high-rise building. The building is, let's say, about 10 stories and above. If you are looking at
Okay.
a situation like that, you know that definitely this building is going to have the axial load that you are going to get at the foundation level will be very high. So
That's
irrespective of whether the soil is a good soil or the soil is a bad soil, you realize that if, let's say, you were doing the basic thing, which is like a pad foundation, you are going to
yeah.
end up with pads that are excessively big, and they are even going to coincide with the adjacent parts from the other columns. Hence, the decision to go in for the pad foundation. Another thing too is that you realize that if, let's say, you were choosing, let's say, a pad, you could end up with pads whose surface area is more than 50% It's more than 50% of the spaces that will be left after the parts have been done. So
Yeah.
then that should tell you that a wrap foundation will be the best thing to go. So people have this notion that, oh, once the soil is weak, if once the soil is weak, wrap foundation. If the soil is good, then you are going in for a pad. But that is not the case. You could even have a good soil, and you will still have to go in for a pad foundation. And then, of course, going for a wrapped foundation, even when you have a good soil. Yes.
Yeah.
So those are some of the things that we need to look out for. Yeah.
Okay.
Sure.
Okay. That's fine. So you can see, Engineer Michael, what you just summarized now is that it doesn't really mean that when you have or when you see a good soil on your foundation, sorry, someone, when you see a good soil on your foundation, sorry, on your soil report, then you just say, oh, since since the soil is good, I'll like go for a pad foundation. No, it's not like that, because most times, for example, if you're designing for a building like 8-story building, yeah, 8-story building, pad foundation might not be that adequate, because we already know that 8-story building is already a medium rise building. Knowing that building are being classified into 3 parts. They have low rise building, they have medium rise building, and they have high rise building and all that. So for medium rise building, it's not advisable to use a pad foundation, even if the soil bearing capacity is okay. Although I'll tell you my experience, which I've gotten in most countries, which I've designed for, even for 25-story building, they use a pad foundation. But I will tell you that even if they call it a pad foundation, it's not actually a pad foundation. So for low-rise building, you have to use pad foundation is advisable if the soil bearing capacity is okay. Now, when do we at what bearing capacity do we use do we choose a pad foundation? Now, when you have a bearing capacity of 75 kilonewton per meter square and above, the first foundation type that should come to your mind is a pad foundation. Now, don't forget, I said what influences your foundation type is one, the bearing capacity of the soil, the nature of the soil, and then the number of stories. What is the building category? Is it a high-rise building, medium-rise building, or low-rise building? Yeah. So right now, if you are designing for a low-rise building and the bearing capacity is 75 kilonewton per meter square, which you have looked at for, once it is 75 kilonewton per meter square and above, the first foundation type that should come to your mind should be a footing foundation, which is also a pad foundation. Now, how do we know what is a medium rise building, or if our building falls under the class of medium rise building? Now, medium rise building is from 5-story and below. Now, once you are designing a building and the number of stories is from 5-story and below, including the ground floor, once it is 5-story and below, then it is a low-rise building. Then, and if your bearing capacity now for that particular structure you're designing for that falls under a low-rise building is within 75 kilonewton per meter square and above, then the first thing you have to design for is for a pad foundation or a pad footing. Because at 75 kilonewton per meter square, pad footing can work if the load of the structure is not much. But even if it's much, what will happen is that you'll be having a bigger footing sizes, but it will work. Now, once you notice that your bearing capacity is below 75 kilonewton per meter square, but not lower than 65 kilonewton per meter square, then the next foundation that should come to your mind should be a strip foundation, which is a white strip foundation, white strip, which is having a ground beam on it, ground beam and a footing. Now, white strip foundation is actually recommended when your bearing capacity is below 75, but not lower than 65 kilonewton per meter square. Now, once you're designing this kind of building, and then you see that you are designing a low-rise building, and your bearing capacity falls within 74 to 65. Once it falls within that range, it is best to try a white steel foundation. Don't think of trying a pad footing, because it is not advisable on that bearing capacity. It's not advisable. So think of trying first a white strip foundation, which is a beam, a ground beam and a footing and all that. Now, if the bearing capacity is below 65, but not lower than 50, the bearing capacity is below 65, let me say from 64 to 50. Once the bearing capacity falls within this range and all that, and it's a low-rise building, think of using a beam raft foundation. Beam raft foundation, think of using a raft foundation, raft foundation. Now, in these two now, raft foundation is of two types. They have beam raft foundation and they have slab raft foundation. Slab raft foundation carries more load than beam raft foundation. So when the bearing capacity is between 55 to 50 kilonewton per meter square, it is advisable you think of a raft foundation. Now, once raft foundation comes to your mind, know that it's of two types. The first one you will try is to try a beam raft foundation. Then when you see that the depth of the beam is becoming too large or too bogus and all that, and there are still some failures and all that in terms of surcharge and all that, then you can then move to a slab raft foundation. Now, slab raft foundation can still stretch itself up to a bearing capacity of 45. It can stretch itself up to a bearing capacity of 45. That's for slab raft foundation. But beam raft foundation cannot stretch beyond 50, bearing capacity of 50 and all that, because at this point you'll be having a very massive depth of beam. For example, I have done a beam depth, a raft foundation beam depth of 2.5 meters, 3 meters, and all that. Now, it's not really advisable that much for you to use that height of beam depth. Instead, it is best to move into a slab raft foundation. Although slab raft foundation is more expensive than beam raft foundation. That's why most people tend to avoid slab raft. They'll just use beam raft even if they're having bigger depth. But know that when your beam depth is more than 1 meter, automatically you have to design that beam as a wall, because even if you are calling it a beam, it is now appearing as a wall structurally, because once a beam depth is more than 1 meter, automatically that beam begins to behave like a reinforced wall. It begins to have all the failure mode. It begins to have all the failure mode that a reinforced wall gets. That's what that beam will also have. So at that point now, when your foundation beam or your raft foundation beam depth is getting more than 1 meter, know that what you are designing right now is like a reinforced concrete wall, even if you call it a beam. All right, that's fine. But beam raft foundation cannot go beyond 50 kilonewton per meter square of bearing capacity. I am still under low-rise building. Okay. Now, once your bearing capacity falls beyond from 45 below to anything, either because I've seen some 15. I've seen 15 before. Bearing capacity 15. So once it falls from 45 below, it is advisable to use a pipe foundation. That's where pipe foundation comes into play. Now, when it comes to pipe foundation, we have several types of pipe foundation, several types, different way of foundation, because the foundation type you will use for a bearing capacity of 30, or let me say bearing capacity of 30 or 35, is not what you will use for a bearing capacity of 5. You understand? And all that. Because at that range, when it's getting closer to like 0 and all that, it becomes very difficult for the foundation, even if you're using pipe foundation and all that. Also, when your number of stories is getting more high, for example, high-rise building, getting around 100-story building, 180-story, and all that, you will see that even if you're using a pipe foundation, you have to use a special, a special type of pipe foundation and all that. The pipe foundation you will use for a 10-story building or 20-story building that has a lower bearing capacity is not what you use for building like 80-story building that has the same lower type of bearing capacity. On the 80-story building area, you are going to use a special pipe foundation. Now, so this is how you choose your foundation type when it comes to low-rise building. Okay, so right now, knowing that what influences our, sorry, if you have any question, you can just use the thumb like this hand button you're seeing here to ask, all right, what I'm saying, all right, something like that. Okay. Let me see. Okay. Sadu Kurema, okay, let me hear a question. Yeah, you want to ask a question, or is that a test? I don't know.
Oh, it's a question. Thank you so much. I think I don't know if you can hear me.
Okay, that's fine.
Can you hear me?
Yeah, sure. Yes, sure. We can hear you.
Okay. My question basically is like when you are working in a site wherein like the soil is rocky, like it's full of weathered rocks, wherein in you to excavate like for let's say like a bad footing or so, you cannot even go less than like 1 meter. You find it's very difficult to for the artisans on site to excavate up to like 1 meter. What kind of foundation do you recommend for a situation like that?
Okay, that's fine. Sorry. Okay, yeah, that's fine. Okay, so now in the area of rock and all that rocky area, for example, let me first of all ask you: have you ever have you seen a high-rise building on top of a rock? I believe the answer should be no.
No.
You understand?
Yeah.
That's one. That's because there is no way you can avoid the rule. High-rise building requires that you are meant to use a deep foundation. Medium-rise building requires that you can either use a deep foundation or a shallow foundation. Now, shallow foundation now is of two types. Raft foundation is still classified as a shallow foundation, even if we still use it for high-rise buildings. They are classified under shallow foundation and all that. Now, for example, for me, I have not seen 10-story building before on top of like a rock. And high-rise building begins from 10-story building. Once a building is up to 10-story and above, you classify it as a high-rise building and all that. So what I'm saying in essence is that when you have a rock and all that, And if actually you want to build on that rock, and your building is of medium-rise building and above, from 6-story building and above, there is no way you can be able to ignore the foundation principle by, let me say, okay, since you cannot be able to dig, or since you cannot be able to excavate, then you just use a shallow, a very, let me say, a part footing and all that, which is not too deep. No, that building will fall, even if you are building on a rock. Now, what they do basically is to see if they can blast the rock up to the required depth that they need. I've seen where they blast rock before. They normally use dynamite to blast rock if actually the clients want to build there. So what they do is to blast the rock, then they will like continue blasting till they'll get to the actual, let me say, for example, if the design of the foundation requires that the depth of the foundation must be 3 meter, or 3 meter, let me just say 3 meter depth, or 3.5 or something. Now they can be able to blast to, if they can be able to blast 2 meter, they will be able to achieve that same foundation they like want to use on that structure, even if they have not gotten up to 3 meter depth, which the design said. Now, what they will do, but they will need to employ a different strategy, which is anchors, foundation anchors. Now, foundation anchors can be able to anchor up to 2 meters into the rock. Now, last time on our meeting, was it last time? Yeah, last meeting we had, I showed you guys about foundation anchors when engineer Akana, from Cameroon, asked about this question. So what they do is that they will need to blast the rock up to the required depth that they want. But if they can blast at least 75% of the depth that they want, they can use foundation anchors to be able to hold down the rest. Because last year, when I designed that 13-story building and all that, now in that country, that I think that's Canada. So that particular place is a rock and all that, and I needed, and that rock, that place, that building also has a basement. So there was need for them to blast the rock and all that. So and that basement was about 4 point something meters. So they blast the rock 4 meters. Now that's just for the basement. Now it now depends. What is meaning now is for the foundation, and my foundation was around 2.45 meters and all that. So they are able to blast 2.45 meters, but there is one particular place that's around the left hand side of the building, about 2.5 meters from the left. That rock there was so strong that if they continue blasting, they might it might damage it might damage like the building that was already existing on that place and all that. So what we did was that since we have already achieved 2.45 meters on this side, that 2.5 meters length that was still remaining, we now went further to achieve at least 1 meter. The remaining 1.4 meters that we were not able to achieve, what we did, we first of all begin to use different strategy and an option by using a step foundation. For example, since we have already achieved 2.45 meters on the right hand side, which is almost 85% of the building length, we have already achieved that. So there are remaining 25 or 20%, no, 15% that is left that we have not achieved the foundation depth. We wanted to use a step foundation, that is to begin to apply step foundation. Then now side that will have a bigger that we have already achieved. Now, during that process, we saw that we will begin to need ground beam going horizontal, going downward until we are not able to connect to this other type of foundation. But I now advise that will not likely be like strong and all that, knowing that the building is already 13 meters and the weight of the building was much because of what we are using it for. Two, that 2.5 meters that we're not able to blast to the actual foundation depth is still much. So what I advised was to use anchor rods and all that. So we use anchor rod for that. So what am I saying in essence? If you're building on a rock, there is no justification that because it's a rock, there's no way you can blast. That means you just build no. You must find a way to blast that that rock if you really want to achieve that you're building and all that. Except it's a, let me say, if it's a one-story building, because that's what most people do. If you go to Portugal, you can see that Portugal Portugal is almost a hilly place. It's almost rocky and all that. And because of that, you'll be seeing some buildings on a rocks. And if you notice, most of those buildings, no one exceeds 5-story. You'll be seeing them 4-story, 3-story, 1-story, and all that. That's because for low-rise building don't require much foundation depth that much. So in the course of that, since they don't require much foundation for them to carry that structure, they tend to build low-rise building on rocks. And since the foundation depth is not much, they won't spend much money in blasting that rock to achieve that, because blasting of rock is very expensive too. So they won't spend much money in achieving that. People that cannot blast rock, what they do is just to, let me allow this data. What they do is to build a one-story building, then use anchors, because once anchor can be able to carry a one-story building on a rock and all that. And they will end up using more partition walls just to reduce the weight of the structure and all that. Okay, I don't know if I've answered the question. Then if anyone has anything to add to the question, let me see, anybody had an experience, maybe you have built on a rock before, then you can also add to the answer that that engineer Kuruma asked and all that. So I don't know if anyone has anything to add to that. Okay, if anyone don't have anything to add to that, or maybe you can add later. Okay, Michael, let's hear from you.
Yes, a quick one. You remember initially where you were asking him whether he's seen high-rise buildings on a rocky terrain.
Yeah.
And he said no. So even
Okay.
for buildings that are not high-rise buildings, we know that
Okay.
for your foundation, you need to have a certain minimum depth
Exactly.
embedded in the soil to prevent
Yeah.
scoring or erosion.
Yeah.
Where you would want to put up the building. And then if you have a rocky terrain and let's say your building is not so high, I don't think the cost of exploding the rock in order to bury your foundation will be very much ideal, or the cost benefit analysis wouldn't make sense. So you probably
Okay.
would want to choose a different location for that. Yeah, that's what
Exactly.
I wanted to add.
Yeah,
Yes.
that's true. So what people also advise, if you cannot afford it, then you can choose a different location and all that. You understand? Exactly. So I don't know, Mr. Engineer Kuruma, if I've answered your question. I don't know if that's okay by you.
Yes. Thank you so much. I think you've elaborated a lot on this issue. In fact, far more beyond to my expectation. And I think the addition of Engineer Michael again is really essential. Thank you so much. I think I've learned a lot.
Okay, let me know. Okay, that's fine. So that's okay. So right now, I was talking about low-rise building and the bearing capacity when to choose the choice of to that. Yeah, can you hear me? Hello.
Yes, 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 I
Yes,
can.
yes, yes,
Okay, yeah,
yes.
sorry for that. So medium rise building are classified when your building is more than 5 story, but that's from 6 story building to 8 story building is classified as a medium rise building. From 6 story to 8 story is classified as a medium rise building. Now, medium rise building, you can still use a shallow foundation. You can still use a shallow foundation, but it all depends. Now, for example, now we already know the classes of our foundation from 75, 75 to 60, when to use or how to choose the foundation types. Now, if we are to design a medium rise building and then the foundation, sorry, you can lower your hand, Engineer Koroma, so that I will not get confused. So to design a medium rise building, all right, from 6 story to 8 story building, and you find out that your bearing capacity is within 75 kilonewton per meter square and above. Yes, you can still test run or try to use a pad foundation first, but know that even if pad foundation will like work for 6 story, you might experience the sizes will be bigger and all that. So at that point now, that is when you have to now bring engineering into play. Now, when you use that power foundation and it has a bigger or wider size, for example, you have 3.5 by 3.5, you have 4 meter by 4 meter footing depth, footing width and all that, and the depth you might be having 450, 500 and above. Now, when you want to, if you still want to use a pad foundation, it is advisable you do a quick, you do a quick you like do a quick cost quantity and all that. The quantity of concrete, that's the volume of concrete that you have to do for a pad foundation. Get the volume of concrete and then keep it. Then you now move to the next type of foundation, which is slab raft. Sorry, which is strip foundation, which is white strip foundation. Now, because white strip foundation is more often recommended to be your default type of foundation for a medium rise building, that from 6 story building and above. Now, you have to test run now for to also design for a white strip foundation. When you have gotten that, then you now check which one is cheaper for the client to afford. Because you, you and I know that when a client sees a very wide footing, even the laborers, they'll start shouting and they end up making the engineer feels as if he doesn't know what he's doing. That how can you use a very big, let me say, a size of a room just to hold a pillar or just to hold a column? You understand? But they don't know that you are working based on the load and all that. So at that kind of situation now, you need to do a do a cost, just to do a quick check on the cost, on the boat cost. Now, when you have done that now, when you have done a quick check on the boat, you should know the one that is cheaper. But based on experience, white white strip foundation is always a bit cheaper than having those bigger size of footing. And most times, your footing will start clashing with each other, causing overlapping. And then you need to find out, you need to look at how to control that overlapping and all that. So it is advisable for medium-rise building, from 6-story building to 8-story building, that what you come to your mind first, it should be a white strip foundation. Now, knowing that white strip footing, white strip foundation has a ground beam. Can you hear me? My this thing. Can you hear me?
Fade off.
Yes, we can hear you, sir.
Okay.
Hello.
Yes.
Okay, yeah. I will call the person back.
Yes,
He's trying to
we
call
can
me.
hear you, sir. We can hear you, sir.
Go ahead, please.
Okay, yeah. I'll call the person back after. Okay, yeah. Okay, that's fine. So right now, for it is advisable building that you use a white strip foundation. That's what is advisable. Now, what people, I believe you have seen some people, they will have a pad footing and still use a ground beam and all that. Yeah, that type of foundation is not actually classified anywhere, because that's not a foundation type, because that's what most people use. They will do a pad foundation, they now apply apply a like a ground beam again on it. They normally use the walls to change the foundation and all that. Now, that alone tends to be expensive and all that. So instead of doing that, why not just design for a white strip foundation which has a beam and a footing of I think around 250 or 200 depth. So I think that's advisable to like use. But the reason why most people tends to, or why most engineer tends to use pad foundation on a medium rise footing is because they don't want to go through the stress of test running 2 or 3 type of foundation just to check the one that is suitable and that is cost effective for the client and all that. Now, that is one. 2, the reason why most engineers don't go as far as test running different type of foundation for a structure once you begin to get from medium rise to high rise is because, one, maybe they don't have experience about that that foundation, for example, slab raft, pie, and all that. So what they know is pad foundation and maybe slightly white strip and all that. So in the course of that, since that's what they know, they will tend to make sure that the foundation design is okay within what they know. Do you get and all that? And I must tell you, having a pad foundation and then using a ground beam of around 450 depth again to chain it, it's actually a penny wise. Let's say no, it's actually wasting the client's money, because the cost, if you actually check the cost or the volume of concrete and the volume of reinforcement you are about to use, you will see that if you use a white strip foundation for that, you won't be spending much on that. Now, so from 75 and above for bearing capacity for a medium rise building, it is advisable you first of all think of using a white strip foundation, because pad footing is not advisable. Now, knowing that medium rise building ranges from 6-story to 8-story building, that's what you can classify as medium rise building. Now, the question is, can you use white strip foundation for an 8-story building? Well, the same thing that happens when you are test running a pad foundation for a medium-rise building, when the size begin to get bigger, is what will happen for an 8-story building when you try to use a white strip foundation. You will see that white strip foundation will begin to go up from the limit of a white strip, because white strip has a limit. For example, knowing that white strip used to have a beam and then a footing under it, that beam of that white strip should not be more than 750 or 850. In fact, it's not meant to get up to 1 meter, because once you begin to get up to 1 meter, you are moving into a beam raft foundation. So that's what happens when you try to use a white strip foundation for an 8-story building. Even say 7-story building, 7-story building might even you be having difficulties, challenges in using white strip foundation, because white strip foundation only works for 6-story and then maybe below. At 7-story, it will be advisable you think of using a beam raft foundation. Okay, now the same thing, if the bearing capacity is below 75 but not lower than 65, even if it's for a medium-rise building, you should think of using a beam raft foundation, because using a white strip foundation, you begin to have your footings under the beam, under the white strip beam, will be getting bigger, will be getting wider and all that. And most times they tend to clash with each other. Two, you'll be seeing that your beam depth going to increase beyond 750. Two, your beam depth also, that your beam reinforcement will now be requiring 25 diameter and something like that. So when the bearing capacity is within 75 but not lower than 65, think of using at least a beam raft foundation. Yeah, I've designed a beam raft before of 850, 800. Yeah, it doesn't mean that a beam raft must be up to 1 meter and above. No, you can still design a beam raft 750, 850 and all that, because beam raft basically carries more load than a white strip foundation. Now, when the bearing capacity now is below 65 but not lower than 50, that's for a medium-rise building, you can still now at this range, you can't try white strip any longer, because white strip will not be suitable. It will fail. It will fail. So what you'll be thinking of now is a raft foundation. That should be what should come to your mind first. You test run a raft foundation. Now, in that raft foundation, now you have to test run beam raft, then test run. If beam raft didn't work, you then test run a slab raft before you can now move to pipe foundation. Note, while you're thinking of all these things or trying to test run, you are still considering what is said on the soil report. If you have to use a shallow foundation or a deep foundation, don't ignore that. Then, once it's below 50 kilonewton per meter square, that's the bearing capacity, and then below, think of using slab raft or pipe foundation and all that. So basically, once your bearing capacity is below 50, and then maybe to 15 to 10 and all that, it is best you think of using a raft foundation and pipe foundation, even if it's a low-rise building or medium-rise building. This is what you should think of and all that. Now, that takes us now to, we have now classified low-rise to be from 1 story to 5 story, medium-rise building from 6-story to 8-story. Now, where do 9-story building falls into? Knowing that high-rise building starts from 10-story. Now, 9-story building now falls in between medium rise and high rise. Now, why do I say it falls in between medium rise and high rise? At 9-story building, you have to testron the both foundation. You testron slab raft or raft foundation and testron pipe foundation that is normally used for high-rise building and all that. So you have to testron these two. Anywhere, any foundation it like falls into, if it falls to shallow foundation, which is a slab raft, then you cannot classify that building as a medium rise building. But if you use a deep foundation for that, it follows a high rise building, because 9-story building, it's just between medium rise and high rise. Most people say high rise building is from there. Most people say it's a medium rise, but basically high rise building starts from 10-story. Once the building is 10-story and above, you call it high rise building. Okay, that's fine. So the same thing you do for medium rise building, you also apply it for a 9-story building. Now, for a high rise building, which is 10-story building and above, at that 10-story building, what you should think of using is a deep foundation. Now, I have told you before that I have seen where they use a raft foundation for a 25-story building. Although that's not in Africa, that's in Albania. Yeah, that's because of the nature of their soil. But even if they use a raft foundation for that, for me, I still call it. I don't think I will call it a shallow foundation actually, because you could see that the depth of the foundation, you can see a beam depth of about 4.5 meters. So at that point, I don't see any reason why you should use that. Instead, you can just use a mini pie. Yeah, pie foundation does not mean that you must have 10 meters, 20 meters, 40 meters. No, length of pie. You can still have a pie length of 5 meters, pie length of 4 meters. I have done a pie length of 3 meters before. Understand? So it doesn't mean that since it's a pie foundation, then it must be from 10 meters long. No, not that. No. So you can still use a pie foundation even if your soil is okay, as long as it's a high-rise building. So what they did there by using that 25 by using a shallow foundation for a 25-story building, even if they have a good soil, although every country has their own country and has that country code and standards and all that. Maybe they have seen that over they have studied their soil and they have seen that over the years that's what works for them and all that. But even at that depth, 4 meters to 5 meters, well, that is still deep enough. So they can still would have used a mini pie, not that. So what am I saying in essence? I'm saying that for a high-rise building, the best foundation type that is recommended is to use a pie foundation, even if the soil is good and all that. Because at the high-rise building, you are not just considering considering just the foundation and just the bearing capacity of the soil. Even if it's above 200, above 100 or something, you are also considering the weight of the superstructure and all that. Because at that height, from 10-story and above, you need a deeper foundation, a deeper foundation to be able to carry the weight or the load of that particular of that story to a good soil strata and all that. Now, as you can see on this screen here, this is about this is a medium height building. Let me see, one, two, three, four, five, six, seven, eight, basically nine story. Yeah, this is actually this Tower of Pisa is around nine-story building, but it can be classified as almost a high-rise building and all that. But if you read about the foundation that was used there, you can see that what they used was a shallow foundation. Although the foundation design wasn't the issue. What was the issue is the soil. So the reason why I'll call it a foundation failure is because foundation failure does not merely talk about your design. If you don't study the soil very well and the soil fails, it's also a foundation failure. So that's why you can see that this is failing. But had they used, although this is many years ago, so you can't really blame them. Many years ago, yeah, you can't really blame them because this is more than how many years now. So had they used a deep foundation, for example, a pipe foundation, you would have seen that settlement wouldn't have happened because what causing this thing to build is settlement. It is soil, is bad. You would have seen that the deep foundation would have been able to carry the weight of the soil to a suitable soil strata and all that. So they would have been able to avoid this issue that's happening now. Although it is still giving them, it's still making money for the country based on tourism and all that. But the main purpose of what the building was designed for or was to be used for is no longer actualized and all that, which makes the building to fail. Because once a building fails for the purpose of what it was is meant to be used for, and it's being used for a different thing, reason being that there was a structural um, failure. If it is to be used for what it was designed for, it will cause a structural failure. That means that the building is already failing. Understand? So for high-rise building, it's good to use a deep foundation and all that. Now, there are techniques that are employed for deep foundation. Different techniques are employed and all that. For example, the techniques that was employed to build the tallest building, the foundation alone, you cannot. I think that foundation type was just introduced based on that building and all that, because the pi foundation, let me say, like the concept of the pi foundation was introduced based on that building as a whole. So if maybe someone now want to study that type of foundation, you need to go and study the structural design of that building and all that. Although what was used to design that, they used the software ETABS. Yeah, ETABS was actually developed for that particular structure, for those buildings in Dubai and all that, because it was between that that year, that was when ETAB came into existence. So that's why they say ETAB is the best it is the best design software when it comes to structural analysis. Like it like gives you different results that you like want to use for any kind of thing. Yeah, ETAB is best for structural analysis and all that. Okay, that's fine. Now let me give room. I've talked for almost an hour. Let me give room for others to like say something too, because I also need to learn some things too.
Hello, sir.
Okay, Okay, sorry for that. So let me just, if you have anything to contribute, which I know you have something to like say, because I need to learn too. You can raise your hand and then say. Yeah. Yeah, Engineer Fashi, let's hear from you.
Yeah, good evening, sir.
Yeah, good evening.
And good evening, everyone.
Yeah, good
Yeah,
evening.
good evening.
Yeah. Sorry I came late and I have some things I've been attending to. You see, in respect to part footing, a lot have been said actually. Today, I think we are concentrating on a part footing, though other times we might still go further on other type of foundations. Now, based on this, that we are discussing on today, which is the pad, I want to say that your column spacing. Hello, can you all hear me?
Yeah, I can hear you.
Yes,
All right.
we can hear
I
you.
want to say that yes, I want to say that another thing that contributes to the sizing of your pad footing also is your column spacing. Because if the spacing of your columns are, let me use the word let me say from 6 meters or 6 meters above, you discover that you expect you can imagine the kind of load that will be going into those columns, which you expect your pad footing to also carry. So this one also, affects your pad footing sizes compared to when you have a closer columns. When you have column very close to each other, you discover that your pad will definitely reduce. Why? Because those loads are being shared. Are we together? Those loads are being
Yeah.
shared. So this one also contributes to your sizing of your pad footing. Another thing is that in terms of, from my own experience, a little, I want to say that pad footing, you discover that the moment you are having up to, let's say, 5 meters, 3 meters, 5 meters, what you normally experience most of the time is your punching, and then this which at times make it bigger, and this what do you call it, your soil bearing capacity, let me use that word, your soil result, though it has been said 75, but your loadings at times and the kind of structure you are designing for, I don't know, I think one of the engineer have said something about it, or one or two people have said something about it. Yes, you might have a bearing capacity that's above 75. You will discover that 75, if you try to use pad in such situation, pad might not actually work because of your kind of structure. It might not be residential. I know that when it comes to commercial, we have a lot of commercials, different kind of commercials, like church, mosque, and the rest. And you know that their loadings are different from just commercial. So all of these actually contribute, not just the bearing capacity also, but your loadings also determines the kind of structure, also determines the kind of foundation you are going to use for your structure. Be apart from what? For your bearing capacity. Yes, anything from 75 years, you can think of a pad footing, either 65 to 74 years. But at the same time, your structure, you might even have a two-story building that will require, two-story building that will require, let me use the word, wide strip, depending on what? On the purpose of that structure, just like the engineer said. So all of this contribute to your what? To your choice of your foundation. So that is why when you are designing for commercial, you should begin to imagine beyond what the soil is saying, the soil report. You should be thinking beyond what the soil is saying, because you are the one designing and you know the kind of load you are putting in. You know, all these architects, there are some things they will add to the structure that will not definitely add more load to the structure. So because the person that is recommending 75 does not know the kind of load that is coming on it. So you are the one that is designing that know the kind of load that is coming on that soil. So it's because by the time you now consider all of those things, from there you can now determine, you can even change what has been recommended. I think I heard the engineer, the CEO, Engineer Justice, mentioning how he changed one foundation like that. Am I correct?
Yeah.
Yes.
So because he was the one designing, he was one that know the kind of load. Excuse me, you are making noise there. He was one that was designing. He knows the kind of load that is coming there, and he knows the right foundation to be used for it. So that is why we need to be versatile in this. I think for now, that is a contribution I want to make. And at the same time, you notice that when your columns are, sorry, your pad are overlapping, there's something we call combined footing. Am I correct?
Yeah, that's true.
Yes.
Yes. So this, all of them are still under pad footing. So this combined footing also, that is why your knowledge of detailing of that pad footing is different from when you're having a combined footing. Why? Because of the forces that will be happening in between, because the load on the other side might be bigger than the other side, the axial load. Are we together?
Yeah, that's true.
Yes, we are together.
So all of these are the things that we need to also discuss so that we can also share knowledge on how do we now go about when you're having a pad footing, because we have had a lot of people talking about they're having a combined footing, but the detailing is carrying like what a single footing, which is very wrong.
Yes.
So the way you detail for a pad footing is also different from when you have a single footing. So, and why are you designing differently? It's just like when you're having a pad combined footing, it's as good as you are. Let me use the word mat raft. You know, when it comes to mat raft, it's both bottom and top reinforcement.
That's true.
Yeah. So now, when you're now having a combined footing, almost have a close relationship. Why? Because we are having two columns of different axial load to be carried by a single member. So, and they have know that those columns are having different axial load, and you expect an is it upstress or something like that. So you now need a top reinforcement to counteract that.
Okay.
So all of this, I think this for now, because I just came in and been on and off, this is what I said. As let me just add to this for now. Thank you, sir.
That's nice one. Okay, yeah, Michael, you're raising your hand. Let's hear from you.
Yes, I think Engineer Olusegun has raised some very, very good points. You know, what you said about the combined footing, I think this seems to be a very big problem for a lot of young engineers. When you see the drawings that they bring, you see that the combined footings do not have top reinforcement. And I think a lot of people also do not really understand the concepts behind
combined footing.
Because I remember one of the things that a senior engineer told me earlier on when I started this journey, that you can take we should really understand the rationale behind why we are putting reinforcement at certain locations. So you could take a combined footing. If you take a combined footing, you could analyze it as, let's say, an inverted beam. Okay, so where the column positions are now become a support, and then the earth pressure now becomes the load on the beam. So now you run the analysis, and then you see that, okay, you have hugging moments at where the supports are, and then you have sagging moments in the middle between the two columns. So after you finish the design, now the reinforcement that you are going to get, you turn it upside down. You turn it upside down, okay? So what you are having as the sagging rather now becomes the bottom reinforcement, and then what you are having as a hugging in the other case will also be reversed, so that they will now be at where the support positions will be. So some of these concepts need to be very, very clear to people for them to really understand, because these days there seems to be a lot of emphasis on software. So if the software designed for you and then you have no way of manually checking if the things that it has designed for you is accurate, then what exactly are we doing? And then you also mentioned punching share. Punching share. I noticed that sometimes people just do the sizing of the pad, or let's say the combined footing, they just do their reinforcement and then they go. The other checks that we are supposed to do, we tend not to do them, especially the punch and share. We tend not to do them, and then we just leave it as that. We don't know whether the thickness of the footing that we have chosen is adequate or not. Yes, so that's that.
Okay.
Thank you.
That's a nice one. That's a nice one. So while we wait for other people to say something, Okay, Engineer. Okay. I wait for another person to like say something. Okay, Nafashi, I don't know. You raise your hand up. Okay, let me hear you, Nafashi. Yeah, Nafashi, let's hear you.
All right, sir. Once again, good evening, all.
Good evening, yeah.
In this case of working check, I think that's the purpose of this talk, so that we can learn as we have just been learning. Because even me, I've learned a lot while my boss was talking, and all the people that have contributed. Now, most of the times you notice that, yeah, the software we are using, they are very, very fantastic. I think last time it was elaborately discussed about how the design, the software came about. You know, there are things that they put into consideration when they are doing those softwares. I think we discussed it last time. I mean, my
Yeah.
God, I think you,
Yeah.
yes, exactly. So now you discover that when you are at times when we are using pad, I don't know if some of us that are listening have experienced it. You discover that at times we are using pad, but your pad is failing at punching. It's showing you that it's failing at punching. So most at times you now discover that if you increase the width, even when you increase the width, it will still be failing.
Yeah.
If you increase the width at times, it will still be failing. So most of the times when our punching is failing, I think the best thing to do is to do what? Apart from increasing the width, is what? The thickness of your pad.
Yeah.
That's where you increase it. So you have to,
Exactly. Yes.
if you don't increase it and you are only increasing the width, the sizes, it will still be failing. So it's the thickness that's the issue. So the moment you increase it, and based on what I have, a little research I've made for a pad footing, I think, I don't know, that's why we are all here, you can still have a thickness up to 600 for a pad.
Yes. Yeah. Sure.
Yes. Yes.
Yeah.
Yeah.
So you can still have a thickness up to that. So if you're having a 2-story, 3-story that is failing at punching, you can have an increment up to that level. Before you know it, you pass your design and do some other checks. So that is
Yes.
another thing I said. Let me also contribute to it, sir. Thank you, sir.
Okay.
Yeah.
Yeah. That's fine.
Excellent point. Yeah.
Yeah. That's fine. Yeah. Basically, this combined footing issue. Yeah, I've seen most of the designs, drawings, and all that. You see that they will have combined footing, but they will just put only the bottom reinforcements, not knowing that combined footing basically used to have a top moment, and for it to push back a top moment, you need to introduce a top reinforcement. Now, most times too, most single footing can still have a top reinforcement. For example, it all depends on it all depends on the reaction on the load happening on on that on that footing. But it's a must for a combined footing that you must provide a top reinforcement and all that. Because, for example, combined footing is used to combine 2 or more columns, and we all know that no no if you have 2 or 3 columns, you can see that the axial loads might vary slightly and all that. So in that, since the axial load varies slightly, you will see that one particular column might, for example, if you have 3 columns now, or two columns, one of them has an axial load of 500, the other one has an axial load of, let me say, 250. You will see that the one that has an axial load of 500, we like try to tilt the footing to like tilt the footing towards towards like towards itself. You understand? Because one, that load on that side is a more compared to the load here. For example, it's like you now and a very fat person is sitting down on a bench. You understand? Or let me say on a lever arm. You understand? Now on that lever arm now, you will see that since your since his weight is more than your own weight, he will try to pull you up and all that. So for you not to go up, you will need another force to what push you down. You understand? Another force to push your shoulders down, or like to push you down for you to have a balance a balance level. So that's what happens also on a combined footing. When you have two different columns that has different axial load, the one that has the highest axial load will want to pull the footing upward and all that. So the footing will be going upward to the will be going to the direction of that one that has a bigger axial load. So for you to counter that effect, you need to provide because that effect alone is called a top moment. So for you to counter that effect now, you need another support at the top to help to push back that effect, which is the top reinforcement and all that. Now, even if two of them, the both columns have almost the same axial load. For example, this one have 240 kilonewton, 240. That one has 241 and all that. You can see that they are almost the same. Okay, let me say 240 and then 240. And now no one is pulling each other up or down, right? Now you'll be saying, how then do a top moment occur? Now, top moment now will like come in at the middle, because for example, you are sitting on a bench, you and the person have the same weight and all that. No one will pull each other up. So you will see that the whole reaction now will go to the middle of that bench. It will try to split that bench into two, because right now, since the reaction cannot go to the end left and right, because they both have equal load at that end, the whole reaction now come to the center. We try to share, like try to bog, like to hug, you understand? Try to break it so that this one can go on its own, this can go on its own, and all that. So at that thing now, it is not creating a top moment at that center, at the middle, in between those two columns. So you still need a top reinforcement to still pull that one downward. But you will see that what you will need might be a slight top reinforcement. For example, the other one I use as an example, where you have a different loads and all that, you see that you might want to, that design might be requiring delta 16 for the top reinforcement, or delta 12, but with a smaller spacing. But this other one that has the same size of axial load for the both columns, that has that reaction occurring at the middle, it might just require a minimal top reinforcement. For example, let me say delta 12 at spacing of 175 or 150 or 200 thereabout. But the whole scenario is that there must be a top reinforcement when you have a combined footing. Yeah, because now most of these contractors, they all have those ideas and all that, even most of these laborers. So if your drawing does not carry that, and let me say that engineer at site does not know that it's meant to carry a top reinforcement, you will see them telling you, Oga, this is a combined footing, you understand? And the way we like normally do it is it also need to have a top reinforcement and all that. They'll just give you as an advice. But if you say no, don't use it, they just leave it, you understand? So know that combined footings used to have bottom reinforcement and a top reinforcement. That's a must and all that. Why for single footing that just have just one column on it? It all depends on the load. But what is more common is that it's just a bottom reinforcement. But at some point, a single footing can still carry a top reinforcement, but it depends on the load coming there and all that. For example, when you apply a horizontal load on a column and all that, you might be seeing that your single footing will be will I need a top reinforcement? Okay, Engineer Michael, let me hear you raising your hand up.
Yes, the single footing. I've seen instances where sometimes the column is not always at the center of the footing.
Yeah,
So
that's true.
you could have instances where the column moves to let's say one edge of
Yeah,
of
the footing.
the part.
Yes,
And
yes, at the edge.
in those instances too, you would have to provide top reinforcement.
That's true. That's true.
Yeah.
That's true. Okay, that's fine. So let me know again who else has something to contribute.
Hello, sir.
Yeah, I can hear you, Engineer Fashion.
Yes. Yes. In addition to what Engineer Michael said,
Yeah.
I think actually there are instances whereby the column will be at the edge of the footing. I
Yeah.
think I've also seen a scenario whereby, though they don't use top reinforcement, but they use what do you call it, beam. Some
Okay,
use
yeah.
beam.
That's a strap beam. Okay, yeah.
Yes, exactly.
Strap
Strap
beam.
to now,
Strap beam.
yes,
Strap beam.
to now
Strap
instead of a
beam.
top beam, they use that. Yeah, exactly. So that to help to, because if not, there will be a form of a. Should I use the word? This I've forgotten the name. Maybe when I remember, I will say. I will
Yeah,
say it. So
that's because the load of that column is not actually centralized on the footing.
so they need that one to
Understand?
counteract the force.
Exactly.
Yes.
Exactly. So
Yes, sir.
you like need a strap beam to not transfer the load.
The load and
Understand?
bring it back.
Exactly.
Yes.
Exactly. Yeah.
Yes.
Exactly. So that's what they do, is to use a strap beam. Yeah. If you don't use a combine, if you don't use a combine, like a doubly reinforced footing.
Yes, sir.
Okay. That's okay. That's fine. Let me see. So let me hear from Engineer Akana. Yeah, you have been here. I know that you say something sometime. So let's hear from you. It's just a discussion. Let's hear something from you. I don't know if he's there. Engineer Kuroma has said something. Engineer Akana, can you hear me? Okay. Engineer I'm sorry, your name, but let me just pronounce Akayazu. Akayezu. I think this is the first time I'm seeing you on the talk show. Can you hear me, Engineer Akayezu? I don't know your name. Akayezu. Yeah, Engineer Akayezu, can you hear me? Okay, if you can hear me, Engineer Oluwatobi. Yeah, you are very active on the group chat. Let's hear from you. Oluwatobi. Can you hear me, Engineer Oluwatobi? Let me see who else here. Okay, I think let me see, someone joined. Let me see. Okay, Engineer Roland. I think Engineer Roland raised he was the engineer that said he works at the ministry sometime on our last meeting. Engineer Roland.
Yes. Yes.
Decker. Engineer Roland Decker. Can you hear me? Okay, Engineer Akayezu said he's here. So let's hear from you, Engineer Akayezu. Yeah, you say you're hearing, but let's hear something from you about foundation design and all that. Just give a hint and all that.
Okay, thank you. Are you hearing me?
Okay, yeah, we can hear you. Which country are you first? Let me know. Is it Nigeria?
No, I'm Rwandan.
Where?
I'm
Rwanda.
from Rwanda.
Okay. Rwanda. Okay.
I think it's the first time I'm here.
Okay.
So I'm still student.
Oh, okay. That's fine. That's fine.
Yes.
Okay.
I'm still student in
Okay.
Rwanda. Yeah.
Okay. Yeah, it's nice. You joining Ekidel while you're still a student, at least you'll be able to have some kind of experience both in design and also in experience and all that. Yeah, it's nice. You're welcome. Is it your first time on our talk show?
Yes, of course.
Yeah, because your name and your face is not familiar, but you're welcome. So I believe we'll be seeing you more and more. We usually have this every weekend Saturday from 6 p.m. to 8 p.m. It's a 2 hours talk show. Yeah, exactly. So why in your school you can also invite your colleagues to Ekidel, yeah, and all that, because the whole purpose is for us to carry everyone along and all that, because we all know how this was tough for us when we are trying to get an idea about structural design and civil engineering. Most people they like normally hide what they know and all that. So most of us learned it in a very hard way and all that. So that you learn something in a hard way doesn't mean it should still continue. You understand? Because we won't live in this world forever. So why hiding something when you can be able to help someone? So also invite your colleagues and your friends to join us on the next on our next talk show, which is next week Saturday. And all that.
Yes,
That's
thank
fine.
you.
But you're welcome. Okay, that's fine. Then engineer, okay, engineer Osan, I think, Osman, I think Osman, Johnny Boy. I don't, Jenny Boy. Yeah, let's hear from you, engineer Osman, Jenny Boy. I don't know if you can hear me. Let's hear from you. Something to contribute about foundation design. Engineer Osman, if we can hear from you, Engineer Richard, Turinawa, Turinawe. Yeah, Engineer Richard, let's hear from you, and Engineer Samson too. Let's hear from you too, and all that. So while we are waiting to hear from them, next Saturday will be, let me see, will be 19th. Yeah, 19th, and our anniversary starts on 22nd of this month, which is on Tuesday. Yeah, on Tuesday. Yeah, but we will start it on Monday, because basically our anniversary is usually 1 week free mentorship and 1 week talk and all that. So we will start on Monday for that 21st for us to achieve the actual 5 days. That's Monday to Friday. It's because if we begin on 22nd, which is the actual date, we will be able to achieve only 4 days and all that. Yeah, knowing that on our last anniversary, we talked about we introduced a max design, although we only did the concept, but on this anniversary, we will do the actual design for like a mask, and we will also do a design of other type of for example, foundation design. We will
Math,
be dealing with, yeah, with a slab
math.
wrap. Yes, lab wrap design, because we have not actually done that, because that's a special course in Ekidel. But based on our rules during our anniversary, we tend to give out free mentorship. So we will be dealing. Sorry, mute yourself. Okay. So we will be dealing with slab wraps and also a mask design, a 20 meters mask design. Then we will then also do a wrapped slab detailing. Yeah, within that 7 days. So other things will like also come up, but these are the major ones that we will deal with. Yeah, I will also introduce a pie shaft foundation, because what we have been doing is a pie cap design, but actually you need to also design for the pie itself. So I also introduced a pie shaft design during this. Maybe that will be on the last day, which is on Friday. No, last day is actually a talk show to now for us to summarize. So that will be on Thursday. That's the fourth day. Yeah, because on the fifth day it's actually for us to summarize all the things we have learned throughout that week, and then question and answer. Anyone that is confused, you like throw your question and all that, and then to share all the documents that was used, all the files that was used during that process. So that's on the last day. So this is what we are coming up with. So there will be no talk show on after next week Saturday. No talk show again till 3rd of May, because that's the next Saturday we'll be having, 3rd of May. Yeah, because throughout that week will be will be the Ekidel anniversary. Exactly, and also we also give out scholarship during this our anniversary. We give out 3 scholarships and all that. So it's still within that period. Okay, that's fine. So basically, we have really talked a bit about foundation design and all that. Yeah, and I really didn't write much about that because of I was busy throughout the weekend and what happened to me. Yeah, throughout the during the week. So, but we will still continue again about foundation design next week, which is our last talk show. So the last talk show now, I think what we'll do is to do a physical design of what we just said now about combined footing, medium rise. We'll just test run all these foundation types using different loads. That's what we'll do next week. Yeah, and all that. So you can get your own scenarios of loads and all that. Yes, you can figure out some loads that will make a foundation like fail, so that we'll be able to use that, and then know when to change from part foundation to wide strip and see the behavior of different foundation types. I think we'll be able to cover that up within the 2 hours. Yes, we can take each foundation 30 minutes. Yeah, 30 minutes. So we have 4 type of foundation of 5. So let's see if we can achieve that within the 2 hours. I think that would be a nice one, because we have just talked about the theory now and the principles and all that and the experience. But it would be nice we like see that physically, which we'll do that on our next talk show, which is 19th of this month, next Saturday. That's fine. Let me know if that's a good idea. I don't know. Let me know that. I'm waiting for that and for your response. If that's a good idea.
Yeah.
Okay, that's fine.
Yeah.
That's okay. Yeah, okay, that's fine. Yeah, Michael, you have something to like say?
Yeah, I just wanted to say quickly that I think this live demonstration of some of these calculations will help. Because even if you think you know how to do it, there is always an opportunity to refresh
That's true.
what you've yes. Yeah.
Okay, that's okay. Okay, that's fine. That's okay. Engineer Fashi, you raised your hand up. Something to say?
Yes, I think it's a
Okay.
very good idea, but from experience also, I want to say this, that despite that we have mentioned what we have planned to do, God helping us, I also want us to have it at the back of our mind that this kind of thing, by the time you start, time might not permit, because we are trying to, to explain. So we have listed out what we have planned to do, but in the course of it, if you are unable to finish, you should be able to understand with us, because it will not be good that we just pick one and talk at the peripheral and you not really understand, and we are jumping to another one. So if time permit, or definitely all that have been said are the things that the company have at heart to really, pass across. I don't know if you get what I'm saying.
Yeah, that's fine. Yeah, like I said
Yeah.
again, we will like try and deal with four type of foundation that day. But even if we achieve only one, let it be that one that we achieved, everyone will be able
Yes,
to understand it, understand.
exactly.
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 Exactly. So even if we achieve only one, because there is still other talk shows, so we can move the rest to the other talk shows later and all
Yes,
that.
yes.
Then yeah, also because of the how busy I was during the week and all that, and some things that happened, I wasn't able to share out. Ekidel has reached 10,000 subscribers. Exactly, which was it happened
Wow.
on Tuesday this week. this week Tuesday, yeah. So, but I was not able to share it and all that. But it's nice. I'm really happy for everyone. Yeah, because without you referring people to Ekidel, we won't be able to reach 10,000 subscribers and all that, which is a good milestone. I really want to say thank you. Although I'll use I'll talk on this later to thank everyone. Yeah, for the 10K subscribers. But thank you for everyone here first, and for people viewing it currently live now. I want to say thank you. We want to say thank you for helping us achieve 10,000 subscribers. Thank you so much, and then God bless you. And we are now is about almost 8, although we are like 11 minutes to 8 o'clock. But I think we will need to end, even if we say maximum of 2 hours. So because different countries are here and they are about 3 hours ahead, most countries 2 hours ahead, which is almost around their midnight now or something, or almost so I think we need to put a stop for today. So see you again on next week talk show, which is the actual demonstration for the foundation design. Yeah, that's fine. I don't know if anyone has anything to say before we say close to today's talk show. Thank you to everyone that is here. Also, please try to recommend your friends and colleagues if you know anyone that's studying civil engineering to also be a part too. Yeah, thank you so much, and God bless you. That's fine. So I think with this, we come to an end to this talk show for today. That's fine. Okay. Yeah. Thank you, Osman. Thank you, and all that. Okay. Then Michael and Fashi, I will chat you up later and all that later after now.
Okay, sir. Okay, sir.
Okay. Yeah. Thank you so much, everyone. God bless you. Bye for now. Then bye. Then yeah. Okay. Yeah.
Bye. Bye.
Yeah.
Bye, everyone.
Yeah. Bye. Yeah. Bye then. Yeah.
Bye bye.
Yeah. Bye then. Hmm.